topic centers around the interpretation of Table 300.5 of the National Electrical Code, or NEC, concerning the burial depth requirements for electrical conduits, specifically in a warehouse setting. Let's delve into the specifics. Table 300.5 outlines the minimum cover requirements for underground electrical wiring. Cover refers to the distance between the top of the buried conduit or cable and the finished grade, which is the final surface level of the ground. These requirements vary depending on several factors, including the type of wiring method or circuit, the voltage level, and the location of the installation. Firstly, it's crucial to correctly identify the applicable section of Table 300.5 based on the specific circumstances. The table is divided into columns that correspond to different wiring methods and locations. The primary concern here involves nonmetallic raceways listed for direct burial without concrete encasement or other approved raceways, which aligns with column 3 of the table. Secondly, location plays a significant role. Table 300.5 provides different depth requirements for various locations such as under buildings, under concrete slabs, and under streets, highways, roads, alleys, driveways, and parking lots. The key is to determine the most accurate classification for the area in question. Given the presence of forklift traffic in the warehouse, the area where the conduit was cut is most appropriately classified as under streets, highways, roads, alleys, driveways, and parking lots. This classification carries a more stringent depth requirement due to the increased risk of physical damage from vehicular traffic. For non-metallic raceways under streets, highways, roads, alleys, driveways, and parking lots, Table 300.5 typically mandates a minimum cover depth of 18 inches. This depth is intended to provide adequate protection against mechanical damage from vehicles and other equipment. It is important to note that the 18-inch depth is measured from the finished grade. In this particular scenario, the conduit was buried only approximately 6 inches below the surface, a couple of inches below the concrete slab. This depth falls significantly short of the NEC minimum requirement of 18 inches. Now, let's address the responsibilities. The NEC itself does not explicitly assign legal responsibility for code violations. However, the responsibility for ensuring compliance with the NEC generally falls on the installer, in this case, the electrician who installed the conduit. It is the electrician's duty to be familiar with the code requirements and to install electrical systems in accordance with those requirements. Failure to comply with the NEC can result in liability for damages caused by the non-compliant installation. The building owner also has a degree of responsibility to ensure that electrical installations on their property are safe and compliant with applicable codes. This responsibility may include hiring qualified contractors, ensuring that installations are inspected, and addressing any identified code violations. In this case, the building owner may bear some responsibility for the damage caused by the power surge because the conduit was not installed to the proper depth. Now, let's consider the argument of under a building. The under a building classification typically applies to areas that are physically within the footprint of a building and protected by the building's structure. This classification generally has less stringent depth requirements because the building's structure provides a degree of protection against physical damage. However, in this case, the area where the conduit was cut is not under a building in the typical sense. It is located in a warehouse area where vehicles, including forklifts, operate. Therefore, the under a building classification is not appropriate. Now, let's consider the argument of under a minimum of 4-inch thick concrete exterior slab with no vehicular traffic and the slab extending not less than 6 inches beyond the underground installation. This classification applies to situations where the conduit is buried beneath a concrete slab that meets specific criteria. Firstly, the slab must be at least 4 inches thick. Secondly, there must be no vehicular traffic on the slab. Thirdly, the slab must extend at least 6 inches beyond the underground installation. In this case, while there is a concrete slab, there is also vehicular traffic. Therefore, this classification is not applicable. To recap, the applicable section of Table 300.5 is Column 3, non-metallic raceways listed for direct burial without concrete encasement or other approved raceways. The appropriate location classification is under streets, highways, roads, alleys, driveways, and parking lots. The required depth is 18 inches. The conduit was not installed to the proper depth. The electrician who installed the conduit may bear some responsibility for not installing it to the proper depth. The building owner may also have some liability for the damage. It is important to note that other factors may have contributed to the damage, such as the contractor cutting the conduit without proper precautions. Determining the full extent of liability would require further investigation and legal analysis. However, based on the information provided, it appears that the contractor's argument that the conduit feeding the sub-panel was installed too shallowly is valid. Now, let's consider some additional factors that could influence the interpretation of Table 300.5. Firstly, local amendments to the NEC may exist. Some jurisdictions adopt the NEC with modifications to address local conditions or concerns. It is essential to check with the local authority having jurisdiction, or OJ, to determine whether any local amendments apply. Secondly, the specific type of conduit used may affect the applicable depth requirement. While the scenario mentions PVC conduit, other types of non-metallic raceways may have different listing requirements or installation instructions. It is important to verify that the conduit used is listed for direct burial and that it is installed in accordance with the manufacturer's instructions. Thirdly, the presence of other underground utilities may influence the required depth. If the conduit is installed near other underground utilities, such as gas lines or water pipes, additional clearance requirements may apply. It is important to coordinate with other utility companies to ensure that the installation complies with all applicable regulations. Now, let's address the question of responsibility in more detail. While the NEC does not explicitly assign legal responsibility, it does provide guidance on the roles and responsibilities of different parties involved in electrical installations. Section 90.21 of the NEC states that the code is intended to safeguard persons and property from hazards arising from the use of electricity. Section 110.3b requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. Section 110.12 requires that workmanship be performed in a neat and workmanlike manner. These sections, taken together, suggest that the electrician who installed the conduit had a responsibility to ensure that it was installed in a safe and compliant manner. This responsibility includes verifying the correct burial depth, using appropriate materials, and following all applicable installation instructions. The building owner also has a responsibility to ensure that electrical installations on their property are safe and compliant. This responsibility may include hiring qualified contractors, ensuring that installations are inspected, and addressing any identified code violations. In this case, the building owner may have some liability for the damage caused by the power surge because the conduit was not installed to the proper depth. However, it is important to note that the contractor who cut the conduit may also bear some responsibility for the damage. The contractor had a duty to exercise reasonable care to avoid damaging underground utilities. If the contractor failed to take proper precautions, such as locating the conduit before digging, they may be liable for the resulting damage. In summary, determining responsibility for the damage caused by the power surge requires a careful analysis of the facts and circumstances. The electrician who installed the conduit, the building owner, and the contractor who cut the conduit may all bear some degree of responsibility. A legal professional can provide guidance on the specific legal issues involved. Now, let's consider some steps that could be taken to prevent similar incidents in the future. Firstly, accurate record keeping of underground utilities is essential. Building owners should maintain detailed records of the location of all underground utilities on their property. These records should be readily available to contractors and others who may be working near the utilities. Secondly, utility locating services should be used before any digging takes place. Before digging, contractors should contact the local utility locating service to have underground utilities marked. This service is typically free of charge. Thirdly, safe digging practices should be followed. When digging near underground utilities, contractors should use hand tools or other non-destructive methods to avoid damaging the utilities. Fourthly, regular inspections of electrical systems should be conducted. Building owners should have their electrical systems inspected regularly by a qualified electrician to identify and address any potential code violations or safety hazards. Fifthly, training and education for electricians and contractors are essential. Electricians and contractors should receive ongoing training on the NEC and other relevant codes and standards. They should also be educated on safe digging practices and the importance of protecting underground utilities. In conclusion, understanding and complying with the NEC requirements for underground electrical installations is crucial for ensuring safety and preventing damage to property. Table 300.5 provides detailed guidance on the minimum cover requirements for different wiring methods and locations. By carefully interpreting and applying these requirements, electricians and contractors can help to ensure that electrical systems are installed in a safe and compliant manner.